Good afternoon. This is my project, my coursework one for AI. Just going through it quickly. So, in this, I decided to go along with the algorithmic trading. Just a quick walkthrough on everything. Okay. So, I went with the algorithmic trading as a domain problem. This is to predict stock markets. And as you can see, I went ahead with the Apple company stocks and I'm using Y Finance, so Yahoo Finance, sorry, as my API. So just quick, algorithmic trading is the use of computer programs to execute trades. My literature review stating the reasons why I chose this. I have my references as well, my statements on ChatGPT. The three AI techniques I chose were the linear regression, random forest, and LSTM deep learning technique. So with linear regression, this is basically just used to establish a baseline trend line. So this predicts if a volume increases by X, which is quite self-explanatory. Now this doesn't really work with the algorithmic because it's a straight line. We need something more flexible rather than that. So exactly what I put in the weaknesses. Financial markets are non-linear and volatile. So linear regression fails to capture complex patterns. But some advantages are it's simple to understand, it's extremely fast, and the results are transparent. Second one is random forest, which basically is a method that constructs a multitude of decision trees during trading. Um, so weaknesses for this one are just like the linear regression. Random forest doesn't inherently understand time as well, and you have to manually create futures in it. And also long short-term memory, which is designed for sequence prediction problems. So unlike standard feed forward networks, LSTMs have peak and feedback connections and memory cell. So LSTM can process a sequence of the last 60 days of stock prices to help predict the 61st day, which was actually what I applied in my project. So I decided to go ahead with the long short term memory. So the domain fit, first of all, so I gave three reasons. So the price today is heavily dependent on the sequence of prices leading to it. So past data, which helps for you to predict what's going to happen to that particular market. And one relevance I see to that to this model is that during our classes and the project brief as well, it encourages the use of deep learning techniques, which LSTM means is perfect for because it's the state of the art deep learning architecture. Performance as well, while computationally is heavier, LSTMs generally outperform static models like the regression in capturing volatile and non-linear volatility of financial markets. I placed a table here to lay out every single feature that they have. So the implementation, as you can see here, I went there basically four different phases: the data ingestion, data pre-processing, AI model, and evaluation and visualization. Data ingestion, as I said before, which we use the API as Y Finance. So this helps to take real-time data into fetch real data into uh what we're implementing basically. So pre-processing, this is what we're doing to normalize data between 0 and 1. um the AI model, the input layer, this is to help accept 3D shapes for the LSTM because that's primarily what it takes on. um from our data format as well, this is the raw input and it's received in generic CSV. And from this column, the date, this is the specific trading days and index price of the market, all the way to the final price and market close, which is our target variable. So in this is part C of the project. So in our code, as you can see, here's where this is every file we need to import to help with the implementation. this particular line, this particular side of the code, this is here to help to produce the same set of results. So not really in the sense of, okay, this is exactly to produce the same set, but if we were to remove this line of code, for example, each time we run it, we'll get different results, which isn't what we want to do. So I added it because we want this dropout to be random, but we don't want it to be random each time. So we want to have a pattern in the results. And I think if you go down here as well, to drop out as well, this also helps with that. So removing this line, basically you get different results all the time, but with this we get same one. So our data collection as well, you can see this is taken from the API our so this can be taken from our finance. Sorry, I'm cracking a bit. So this is basically where we get data from Y Finance. So for processing the data, for processing the data, we're using 80% of training and 20% of testing. First of all, we scale the data from 0 to 1, and then we use the 80% for training the data. Then we create a window size. We create a 60-day window size for the data, and basically this helps us predict the 61st day. And after creating this window, we turn them to NumPy arrays, and then we reshape this data into 3D that the LSTM can accept. I'm sure I'll have more time to go through all of this in depth during the Viva, so I'm just gonna skip to the results. So here you can see our data, and these blue lines is the data we use to train our model. So if we were to go down here, we can see, so the blue one trains the data. The orange one in here is the data that we haven't fitted in our model to be trained yet, but is kept for testing to ensure that our results are basically accurate. And the green ones are the green one, and the predictions are the green ones, and as we can see, they match the orange ones, so it seems to be good. Also, I plotted this prediction prices. I plotted the predicted prices against the actual prices. It's around the diagonal line, so this means that the predicted price is kind of equal to the actual price, which is really good. And up here as well, you can see the R square score, which is at 92%. So that is near perfect as well. The RMSE is at 1.23, which if we do compare here is to the prices here between 150 even all the way to 190 is really good. Near perfect. So going down to this assessment of effectiveness, the R square score is at 92%, which confirms that our LSTM is highly effective for this specific domain. To improve this, I will say first of all is to incorporate leading indicators such as trading volume RSI as input features. Also, we could feed financial news headline directly into the model using NLP, which a pre-trained NLP, to help it anticipate sudden market shocks. So the strength for this is I achieved a very low error rate of $1.3. This proves that the LSTM is far superior. And yeah, I'm pretty running out of time. And my sustainability, the IMO is good for data. For environmental is to use pre-trained models again. edge computing run an interface on lower power local devices rather than massive cloud servers, and then to use green cloud providers host the algorithm on cloud servers like Google Cloud or Azure, which uses 100% renewable energy. I'm pretty much going to have to stop it because I've actually gone above my 10 minutes, but I'm so sure have sorry I'll have much time to properly explain this during the Viva. Thank you.